Hello everybody. So this is a demonstration of my device that I've come up with that has proved itself to be very useful for a lot of different redstone builds, particularly in this mini game I'm creating of Catan Jr. But I could find that this would probably be useful in a lot of different redstone builds, especially if you're working on redstone computers and other large redstone builds. So I'm just going to explain the device quickly now. We have four inputs, input A, B, C, and D. And then a reset button, or I call it the clock, because a lot of the times in certain situations you're going to be using different forms of clocking to work with the machine. It essentially allows me to put in a different 4-bit program in here, and then I can engage it. And then when I can play with the inputs once it's engaged, and it won't register on there until I've reset the clock completely. So I'm going to first show you how I built it, which is very simple. I'll build one right here in this slot, the same way I built that after I demonstrate it. But it has this memory locking unit hooked up to the clock, and then the clock also moves around to engage into these 4D flip-flops that I have right there, and the clock then goes down into here and engages these four piston locks that I created. It will deactivate the locks, because right now the locks are active. They are always active until the clock is turned on, which is very crucial to have this little part in order for this to work the way we want it to do. Just to show you how I built those, I have 4 sticky pistons with 4 slime blocks, and the way that the slime blocks doesn't pull everything around it around, you will have to use glazed terracotta in a pattern around here. It's even under here, in order to make sure that nothing else gets pulled back down or up when the sticky piston pushes the slime block up and down. Only this block here will get moved by the slime block and pulled back down, and that's why you have to have a slime block. Right, let this autosave. It is crucial that you use the slime block and you use the glazed terracotta to make this portion of it work. Now, let's give you a quick demonstration of how it works. So, I want input A and B to be on. They are on. By the way, the lights are in the same sequence. A is A, B is B, C is C, D is D. Same order of lights for the outputs as the inputs. Alright, so now I engage the clock. 1 and 2 turn on. While the clock is engaged, I may add another bit in, and it's not going to show up. Same with this bit. I can add that. I may even take out this bit if I wish to. So now if we were doing 4-bit binary, we'd have 1, 0, 1, 1, and that I have pre-programmed. Right now it's 1, 1, 0, 0, as was the last program. I can now change the program by resetting the clock. So turn off the clock, and then we turn the clock back on, and now only 1, 0, 1, 1 will show up on the 4-bit binary display up there. I can again change if I wish. We'll leave that one on, turn off, and then on. It does seem to retain a little bit of memory from the last sequence before it makes the change. I will try to work to get that out of the system. That may actually prove to be a bit of a downfall for what I'm using this for. But for the most part, what I wanted this to do is working. I could not find any device like this on YouTube that worked. I tried 4D flip-flops. I tried 4D flops going into 4 more D flops. That did not work to do what I wanted. I tried making 2 of these little memory converters. That did not work. It seems the only ways to have these, this memory lock, this 4-bit memory lock with this 4-bit D flip-flop, with this piston lock engager. Without any of which, this system does not work the way you want it to do. I do not know what the name of this exactly would be, although I can find 1,001 different uses that this thing could be very useful for a Redstone computer, for Redstone builds that require 4 lines that would have to be changed but can't show up through the system until you reset a line. So I find this very useful. It kind of works like an AND gate, almost as if the AND gate on one of the input A was divided into 4 and input B was separated from those 4 inputs, but it's definitely more than just that. This thing is 100% useful to almost anyone that likes to work with advanced Boolean logic circuits of any kind. So now let's get into the build. So the build is fairly simple. First, you're going to build the memory locking circuit. So what I'll usually do is I start from the center. Like this is a little, like these little slots are going to each contain one, so that I've already pre-built it. I built 4 going down. You don't have to go 23 this way because you still have plenty of room behind it. But in my build, I need it if I'm doing my extra stuff that I'm going to do with this circuit. So let's just see how it works. So I start off here, and I'm going to build 1 here, 1 here. This can be any block of your choice except glass, as you cannot put redstone on glass, but you can essentially use anything. Right now I'm using concrete. I have purple concrete. So what I'll start off is I'll put this little piece there, then I come back this way, put 1, 2, 3, make a little T out of it, cross or T, whatever, poke out the middle, put a piece of redstone down on the middle. Then you're going to put 4 repeaters up here going like this. It is crucial that you have this one going this way and that one going that way. This is where the outputs are going to go, and you have to have one going into it to make sure this locks. The whole point of this memory locking circuit is that you use the repeater's locking ability when you have 1 repeater feed into 1. Then you'll want to come down here and build the same thing you did up there down here. So 1 repeater that way, 1 repeater that way, and make sure the out one's going out in that direction. The way with a repeater works is that the signal will go in, no matter how small of a signal goes in this way, 15 will go that way. On top of that, the signal will be allowed to go this way, but if something happens to the signal and it gets activated over here, it will not flow backwards outside of it. Kind of like a diode in a sense, in a real electrical device, but in Minecraft we have repeaters. They also have a delay ability, so you can delay the signal before it gets outputted here by a game tick. I believe a game tick is like a quarter of a second or something like that. So you could create delays in your circuits by going, this is a 1 tick delay, 2 tick, 3 ticks, 4, up to 4 ticks on each repeater. If you need more than 4 ticks, you can just place a repeater after repeater after repeater. It doesn't matter. And you can just 4, 8, 12, 16 tick delay if you need. Not necessary in our build. I'm just explaining a repeater for those who do not know what they are and how they work. Alright, so essentially this is the build. We just got to basically do the wiring. So you're going to build this here, and this here, and this here, and this here. This will be able to allow us to make the circuits work. So how I usually do it is I'll go one this way, and then we'll make one go like this. Oop, okay, I did that wrong. What am I doing wrong? Oh, yeah, we should probably put this up here, this up here. So now we got one that goes there, one right here, one that goes down this way, and one that goes this way. So now you got 4 lines going into this memory locking system. Now you want to make the 4 lines going out. You just build the lines the exact same way we built those lines. And essentially that's it. You can also start to build where the clock will go. So this is how I usually build the clock, and I'm just gonna double check to make sure I'm doing this right. So we got one going that way. We'll keep on this one for the sake of everything. The clock's always going to remain green. I change everything to purple when it comes here just to designate this as a unit. So now that we created one there, we can go up, up. Then I think it goes down. I'm just going to double check. Actually, I think it goes like that. Over there. Yeah. Alright, now we're good. So, now that we got that. Oh, and don't forget a repeater going in this way, because this is where the signal is going to go in and affect the system. Alright. Now we can start, put our clock line out, and we'll give it a switch. By the way, you don't have to use a switch. This could be a line coming from another device or anything. In my mini game, it's actually a dice. So depending on which dice goes through, the dice is going to be the clock. So on that one, that's if the dice hits 1. If the dice hits 1, it clocks in that register. I'm calling them registers just because I don't know the name of this device. So we will call it a register for the sake of this video. Alright. Now that we created that, we can now begin to build the D flip-flops. So the D flip-flops are connected right after and are also connected to the clock as well. So we will start off by placing the repeater down here. Then we will make the D flip-flops in this one red. That actually we'll just keep it purple. So we want to go 2 blocks high, 1 block out from these blocks. We want to connect these blocks together. Actually, we can change this is going to be the line for the clocks. So just for the sake that we know that the clock line's going to run over here, we're going to change that to green. This is why in my system I just made it all one color, because it's easier to recognize that way, but since we're doing it this way, we're going to do it that way. So you guys can get a clear understanding as to what's really going on here. So now we can connect our clock. So now the clock, it will go through this and then also through this. So on top of each of these, we're going to place a repeater as well. And then extend them by 2 like a crane. So it looks like a little mini crane. So that's 2. And then on that second block, down 1 level, we're going to put a block here. Piece of redstone dust next to that. And then 2 torches, redstone torches, going like here and here. And do that to each one. Alright, swing around to this side, and on this side of that bottom block that we placed, we'll put 1 there, 1 there, 1 there, and 1 there. We then, and we will need a torch on the end of each of these, making sure that this signal over in between is going to be inverted. And then we placed our redstone dust lines up here, past this repeater, and then we can connect our clock. Make sure you place a repeater here so this line doesn't get connected to this line. So we bring these all the way around. Always remember, a redstone signal loses its strength after 15 lengths. So each block is a length, so we'll say after 15, you're going to lose your signals because it loses strength as it goes. You'll need to place a repeater on that 15th block in order to keep it going, the signal going. So I always, for some reason, have to make sure that everything always moves smoothly enough that it's always in between. I'm just going to copy off this side, which I put 1 right there. So if that one works, we know this one will work if I do the same. So we'll put it here. That is definitely less than 15, but it's always good to make sure your signal's moving rather than stopping, right? Next step, we're going to start, I believe that's the D flip-flops. That's the memory locking circuit. So that's all completed. I'm positive I got everything. The next step, what we'll do is start to make the last part, which is this little locking device I made with the pistons. So the way I made that was coming, so let's double check on this side. I went straight down, a stair over, and then stairs. So we'll go and we'll make sure to use green still. I think it was right over as soon as I got in, right? Yeah. I think this is crucial as well, because if we go over here, the signal here is going to be affected by this torch. So we want it to not get affected by that torch. By the way, underneath my 4 foot, I also, after this layer, I dug down 2 more layers to make sure I had room to make room for the pistons. You will want to keep that in mind, unless if you're just making like this on a quick thing and you're not doing it inside a port. So let's see, we want to go one there, one there, we're going to go one in, and then from that I believe we just go all the way and go this way. If you're building underground, you may want to put in some torches around just so you can see. Not important for us right now. So after each of these repeaters, because this is where the outputs will go, we're going to want to cut a square in each one of these. Go one there, there, there. Wait a second. Nope, nope. I'm doing this wrong. Or no, I'm not. One there, one there, one there, one there, and one here. I'm doing this wrong. Or, no, I'm not. Okay, because we're also going to be poking out these. Keep that in mind. That line will be gone. And we want to cut out like a little zigzaggy pattern in here like this. Now, in the teeth of this, we're going to use glazed terracotta. Can be any of your choice color of your choosing. For the sake of this, I'm going to use purple, we'll use the magenta because it has arrows and we can use the arrows to our advantage. If you're going to use the arrows, always remember, go to your left and go to your left and you'll get it to go in that direction. So this is going to show that we're going to go that way with the signal. If I were to make this go on any different part of the block, the arrow would go in a different direction, as you can see. So you got to be careful when placing these in with making sure the arrow is going to go. I don't know if it matters if all the arrows are going that way. Sometimes I like to make it so when it's at this point it points in on them, but that's not really possible, so we'll just keep it this way. That way we know the signal's going that way. Completely unnecessary, but kind of fun. Alright, next we gotta grab sticky pistons, slime block, and we place them in. So one thing I'm realizing here is this is not far enough, which doesn't seem to make sense to me unless if I did it different. Yeah, I did extend it. Alright, so as always, you can't remember everything off by heart. We're putting one down on each of these. Slime block on each one. And then we take like I said, a block of your choice. I'm keeping usually most things of this machine purple, unless if it's the clock line for now. Alright, so those are initially set, they just need to be wired in. So this is going to bug me now that I did it wrong, so we're going to change these over. The line wasn't supposed to go through this spot. It was supposed to go two more down this way. You want it to be not right next to it because the line will just feed right past it. It's got to feed into each piston. Pistons only work if the redstone line is fed into the device itself. So we're going to cut through this way and place our blocks like this. Alright, now they're in each piston. we now can lay down the dust down. Place your piston here and your repeater here, sorry, and feed your line up. Over this way and up until it's connected. Now that's connected to the clock. This is connected to the clock. And this is also connected to the clock. The clock has control of each of these devices. And the input will kind of surge through and be decided by this circuit. Now, I'm not going to go as far as making a screen, or maybe I should just for example's sake, but yeah, I guess it wouldn't hurt. Oh yeah, after this, you're probably going to place a repeater here, most likely, depending on how long your signal to the output is. Usually it's going to be far, so put a repeater right after, so the output will go into this repeater and send the signal on that way. It wouldn't right now because the clock is off and the pistons are retracted inward, and it will only it'll only work when the clock is on and the pistons retract outward. And that would make this your output right here. The final output goes here. So whatever you want to hook up this device, however it may be useful to you, just remember your inputs will come in right here into this device. The clock line will be decided through here, or your other input per se. Consider, like I said, if it was an AND gate, that would be input A divided into 4 different inputs, and input B coming through here. But I believe the proper terms would be inputs A, B, C, D, and clock C is what they call this. So anyways, these would be the outputs. So let's build a line of these. Just so we'll be able to see the lights from the other end. That's the reason why I made this part. Now keep in mind you don't need these ones. If you want, you can remove them, and that kind of creates more room to work it with underneath here. If you're ever making stairs, always remember in Minecraft you can literally make them completely diagonal from each other, as long as they're not sand or other blocks affected by gravity. I'm just going to leave those ones, it doesn't matter. And then finally place some, whatever your output is. So we're going to just say lamps, because they're the easiest to see from a distance. You could put pistons, you could put anything. You can have these hooked up to anything you wish them to be. But in this sake of understanding things, we're just going to use the 4 lamps. It's probably going to be hard to see them from here, so what we're going to do is break away some things from here. You should be able to see them. It's hard to tell if they're turning on or off because they don't have a black screen like I made on these ones. But if you look from that side to that side, you can see an on one is definitely distinguishable. So, oh, and always remember, if you're going to use this machine, you're going to need input devices of any kind. Like I said, you could have the inputs be friggin' pressure plates or anything you wish to put them as. I'm going to just put some levers, because levers are the easiest to make an on or off state when you're manually controlling a line. So inputs A, B, C, D, and the output, or the clock, the whatever you want to call this. This isn't an output at all. This is a clock or a reset. You can call it a reset, you can call it a clock, whatever you want to call it, it's there. Alright, so just to test that it's working, nothing comes on unless if I click this on. And for some reason we didn't get an output. Oh, and it helps if you wire in your device to your output device to the machine. So 1100 1100 1010 1010 1001 1001. So, thanks for watching. I hope this video may be able to help solve someone else's problems, or have inspired anyone to try anything like it or better, or could make a video explaining devices like this and what they are. Because again, I have no clue exactly what this is. All I know is it works very well, has very good use to a lot of things, is fairly compact for such a complicated circuit. I could think of 1,000 ways to make this a lot worse on a person. So, yeah. Please give me a comment on what you think. If you liked it, you didn't like it, like or dislike. Any feedback is generated will be useful for me towards how to make this circuit better or not, or my videos less boring or not. I love feedback. I love comments. I love Redstone in general. So yeah. Again, looking for the true name of this. So anyone out there, please leave a comment with the name if you know it. Anyone that knows anything about logic gates and whatnot, please give me the answer. Alright, thank you. Have a good one. Bye.